Okay, so we're into another mechanism, and this one's a biggie. It's simple in its form, but it's super useful. The name of it in Bruce text is nucleophilic addition-elimination, and I'd like you to think about why that name makes sense. It's not just a big name. It's nucleophilic addition-elimination. In other texts and other authors may call this nucleophilic acyl substitution. So this is a big one. All right, so the thing you want to memorize for this is that. Okay, you've got your acyl group. Agreed? Here's your acyl group. And you've got your nucleophile here. Okay? And you know what that is, right? That's a leaving group. Okay, so let's put a negative on that. You know, some nucleophiles are charged, some are not. So let's keep things neutral. Let's look at this like this. Okay, so you know what's going to happen here, right? Every time you do a mechanism, you identify the most active electrons, and we're going to call that nucleophile. And number two, you identify the most vulnerable nucleus every time, every mechanism, right? And then three, of course, you connect. Boom, of course. All right. So this is the most active. These are most active electrons here. This is the most vulnerable nucleus. So what we have here is boom. Okay. Now that carbon's already got 4 bonds on it, so it's going to have to kick somebody off. All right. I'm going to do this down the page. Okay. And that's the nucleophilic addition step, right? We just added the nucleophile. Okay. Now, since this is nucleophilic acyl substitution, we're expecting that we're going to get a substitution just like SN1 or SN2, right? And with our SN1 and SN2, we had a nucleophile come in and a leaving group leave. So in this case, this is going to come back down here and the leaving group's going to leave. Okay, and that's it. I do want to make some comments about this because we have a minute. And I want you to think about what's going on here. The way that we can push this reaction, there's a couple things going on here. Number one, we have a good nucleophile, factors. Good nucleophile, right? Second thing we have is a good target. And third thing we have is a good leaving group. How do you spell group? Let's suppose that's group. Does that have 2 O's? G-R-O-P? Perfect. Alright, so we have a good nucleophile, a good target, and a good leaving group. So what does that mean? That means that this leaving group is stable on its own. Okay, and we can identify that, whether that's stable on its own with the pKa tables. Ask me how. We can identify if that's a good nucleophile, also with the pKa tables. Ask me how. And we can also, what's the third thing? A good target. Alright, yeah, look at this. So if these electrons are being drawn off here, you already know it's a good target because it's trigonoplanar, which we learned in lesson 11. It's trigonoplanar. Boom. And it's partial positive. So it's a good target. But we can make it a better target if we do a couple things to it. For example, and let me just give you one example here, and it's going to come up in some future. Here, sorry, that was off camera. For example, and we're going to deal with this more in future videos and future mechanisms. But watch this. If we take that, suppose the nucleophile is not so strong in this in a particular scenario. Okay. If we take this and we add a proton to it by HCl. What do you think is going to happen? Maybe you should pause the video at this point and make a guess. Ideally, you'll do that. Do that. Okay? Alright, let me suppose you did that. Here's what's going to happen. Right? You protonate that. Now let me ask you, what did we just do to the electron density of that carbon. It was partial positive. What is it now? Okay, that's a good thought question. Let me put a big box right there, and which will remind you that that's a question which I would like you to be able to answer in class. All right, so that's nucleophilic acyl substitution. Oops, I said that on accident. Bruce calls it nucleophilic addition-elimination because we're adding a nucleophile and then we're eliminating a leaving group. And it's acyl. That's an acyl group in the yellow. Okay, nucleophilic addition-elimination mechanism.